Hi everyone and welcome to Tutor lessons. Today I'm going to be focusing on quadratics and I want to focus on completing the square. Now if you haven't seen any of my previous videos and you would like to start from the very beginning, please click the link above me right now and you'll be able to start the series from the start and work your way through the videos. So today we're going to be looking at completing the square and we're going to be taking a look at a really useful method on how to complete the square. I like to call this method the sneaky method, but in mathematical terms it's actually called equating coefficients. But I think sneaky method sounds a lot better. What do you think? Right, so let's dive into completing the square and using equating coefficients. Right, so completing the square is a process of converting some quadratic ax squared plus bx plus c into the format of a x plus p squared plus q. Now, the process that I'm going to show you works a little bit backwards. It's almost using the form that they wanted you to work with against them by converting it backwards into the original format here, the quadratic form, the standard quadratic form. Right, so what we're going to do is we're going to expand the right-hand side. So I'm going to rewrite my two brackets just so that my FOIL is correct, plus q. And now we expand the brackets themselves before multiplying in the a. So I'm going to ax squared plus px plus p squared plus q. I'm going to simplify those. So it's going to be a times by x squared plus 2px plus p squared plus q, and then lastly I'm going to multiply that a term, so we're going to get ax squared plus 2apx plus ap squared plus q. Now this is where the sneaky method comes in, because we can now relate our original quadratic equation to this new form. So we see the a terms are the same. We see that this b term from our original quadratic is equal to this 2ap term, or coefficient for the x term in this expansion. And we can see that our constant c has to be equal to ap squared plus q. And this is why I call it the sneaky method, because we're basically overlaying our expanded form over our original form and then solving accordingly. So let's apply this to a question and then we'll look at a more difficult one and hopefully you guys can apply it in there. Pause the video obviously at that point and then see if we get the correct answers. Right, let's take a look at question 1. So here I've got x squared plus 7x plus 1. And this time the question is asking us to put it into the form of x plus p squared plus q. Notice we don't have an a term, that's absolutely fine. We're going to use the same process here and solve. So we are going to expand, giving us x squared plus 2px plus p squared plus q. And now we're going to relate the coefficients for our original quadratic with the coefficients of our expanded form. So we see that we have a plus 7 as our b, and that's going to have to equal to 2p. And the reason why we relate these two is because they both have these x terms, right? So the x terms have to be the same in order for the form to be the same. So we can then say 7 must equal to 2p. And then I'm going to divide both sides by 2 and get the value of p. Therefore, p must equal to 7 over 2. Right, so there's my first constant solved. Now I need to find the other constant. And we see that this plus 1 has to be equal to p squared plus q. And so I'm going to equate the two of them. So I've got 1 must be equal to p squared plus q. But the cool thing is we already know what p is. So we're going to substitute it in. 1 is equal to 7 over 2 squared plus q. and then we're going to expand the bracket, so it's going to be 49 over 4 plus q. And so now we can take the other value to the other side and solve for q. So therefore my q value is going to be 1 minus 49 over 4, and that is equal to minus 45 over 4. Right, so now I've got my two constants for my completed square, and now I'm going to write it in the completed square form that they asked for. So therefore, my completed square is going to be x plus 7 over 2 squared minus 45 over 4. And so here we have our completed square. Right, so let's tackle a more difficult completing the square, or looking at an alternative form that they might ask you in an exam test situation. And that's where the sneaky method shines. So let's take a look at question 2. So question 2 wants us to put it in a very weird format, which isn't your standard completing the square. And so they say 9x squared minus 6x minus 3, and they want us to put it into the form of ax plus p squared plus q. So here we see that the a term is now within the bracket. So we're going to do the same procedure. We're going to expand, and then we're going to compare our coefficients and then solve. So we're going to get ax plus p plus q. Then we expand using FOIL. A squared x squared plus apx plus apx plus p squared plus q, and then we simplify. So we've got a squared x squared plus 2apx plus p squared plus q. So here we're going to see that our constant for our x squared term must be equal to a squared. Our constant for our x term must equal to 2ap. And our constant for our c term, or our constant term in our quadratic, must be equal to p squared plus q. So now we're going to make them equal to each other, solve, and get our values of a, p, and q. So firstly, we see 9 is equal to a squared. So therefore, we square root both sides, and we see that a must equal to 3. So here I'm only looking at the positive square root. My next equation is minus 6 must equal to 2ap. So here what I'm going to do is substitute in my value of a and then solve for p. So minus 6 is equal to 2 times by 3 times by p. Minus 6 is equal to 6p. Divide both sides by 6, and so therefore p must equal to minus 1. And then lastly, I need to find my value of q. So my q value is going to be minus 3 is equal to p squared plus q. I know what my value of p is, so I'm going to substitute it in. Minus 3 is equal to minus 1 squared plus q. And we know that minus 1 squared is going to equal to 1. Take that over to the other side, and so therefore q is equal to minus 4. And then all we need to do now is write down our final answer in the form that they wanted. So therefore, we're going to have 3x minus 1 squared minus 4. And here we have completed the square in this alternative form. I hope you guys found this video pretty handy. If you have any questions, please feel free to leave a comment in the comment section below. If you really enjoyed the video and you really enjoyed what we do here at Forrester Tutoring, a subscription to our YouTube channel would be absolutely fantastic. And if you have any further questions or topics that you would like me to cover in future video series, please also leave those in the comment section below. Cheers.